It's important in chemistry to speak qualitatively about compounds. Quantitatively would be to identify them, qualitatively would be to measure the amounts of the compound that we have. So let's find the molar mass of something. The molar mass is equal to the mass of each one of the atoms, and we have to take into account how many atoms there are. Okay, so the first thing I'm going to do is list the atoms that I see. I see sodium, sulfur, and oxygen. Then I count the number of atoms that I see. There, by subscript, are 2 sodiums, 1 sulfur, and 4 oxygens. Then I multiply it by the mass for one atom of each type. 23 for the sodium, 32 for the sulfur, 16 for the oxygen. Multiply these terms together. That would be a total of 46 for the sodium, 32 for the sulfur, and 64 for the oxygen. Add that up, and 1 mole of this compound has a mass of 142 grams. All right. Sometimes it is helpful to find the percent by mass. The percent by mass is the mass that each one of the elements in a compound adds to the total mass of the compound. So the question, the way we do this is we find the percent of each one of the elements in the total. All right, it says what's the percentage of carbon in C2H6, and what is the percentage of hydrogen in C2H6? Well, we have to know what the entire compound, the mass of the entire compound in order to find each individual element. So there are just the 2 elements. There are 2 carbons and 6 hydrogen. Carbon has a molar mass of 12 and hydrogen 1. That would be 24 grams of the compound from carbon and 6 grams from the hydrogen. So the entire compound has a mass of 30 grams. To find the percent of carbon, we take all of the carbon present in the compound and divide it by the entire compound's mass, multiply that by 100, and we get 80%. The percent by hydrogen better be the other 20% since there are just the 2 elements, but we'll do some math to make sure that we are correct. 6 divided by 30 times 100% is 20%. Remember that your mass percent can't add up to anything except 100. The empirical formula is the simplest whole number ratio of atoms held together in a compound. It can be done from elemental analysis, and it also helps us, we can also figure out from the percent composition. Remember, it's a ratio of atoms or moles, not a ratio of mass. Here is the procedure. If you're given a percentage from a percent composition, turn it into grams. Assume that you start out with 100 grams. Convert grams to moles, and then divide by the smallest so you can get a ratio that is 1. And then multiply till you get a whole number. There is a small poem that you can remember from Chem 1 that I can't remember right now. Use it if you like. So the first thing we have to do is we are given a percent composition for a compound that has scandium and oxygen in it. It is 65.2% scandium and 34.8% oxygen. We will change those percent signs to grams and assume that we have 100 grams of our compound to find the molar ratio of these atoms. So I need to find the number of moles of scandium equal to 65.2 grams of scandium. The molar mass of scandium is 45.0 grams. When I multiply the top divided by the bottom, I come up with an answer of 1.45 moles of scandium in this compound. The number of moles of oxygen in 34.8 grams. Is equal to 2.18 moles. I need a ratio that is whole numbers. It would be inappropriate for me to write the formula of this compound like this. Only whole numbers as subscripts. I can get a whole number right off the bat by dividing this by the small, by itself. The small is divided by the moles of each one. Now I have at least one. This is 1.5. It is also inappropriate to write this. So I have to find a common factor that will turn 1.5 into a whole number. That would be the number 2. What I do to one, I do to the other. So these become the subscripts for my compound. So the ratio of atoms is I have 2 scandium to 3 oxygen. Whole classes of elements have an empirical formula and then something called the molecular formula. A lot of organic compounds have an empirical formula, and then there are compounds that have whole number ratios that are multiples of the empirical formula. This is a molecular formula. This is an empirical formula. If you have a molecular formula and you are asked for the empirical formula, just simplify. 3 and 6 can be simplified to that. Okay, it says the empirical formula of a compound is CH4. It has been determined that the molecular formula has a molar mass of 32. What is the molecular formula? You take the molar mass of the molecular formula, divide it by the molar mass of the empirical formula, and that gives you a value n. You take the empirical formula and you use that n as a multiplier. First, we have to find the mass of the empirical formula. So there's 1 carbon, 4 hydrogens, and we can see that the molar mass of the empirical formula is 16. We take the molar mass of the molecular formula divided by the molar mass of the empirical formula to get our n value, our multiplier, and our multiplier is 2. So we take the empirical formula and we multiply the existing subscripts by the multiplier to give us the molecular formula of C2H4. The percent purity is another way we can describe a compound. It's the mass of a pure product in the whole mass. The higher the purity, the closer the solid is to being a pure substance. In a 5-gram sample of iron ore, only 2.5 grams is actually just the iron. The rest are contaminants. What is the percent purity? The percent purity would be equal to the percent of, the mass of the pure, which is the iron, times the mass of the whole ore, which is 5 grams multiplied